In the last video, you saw how to generalize the algorithm to test if a number is prime. Now we're ready to translate that into Python code. We're going to do this in a setup that's going to look like the labs you'll do in the rest of this specialization. We'll get to that soon and have an introduction to using this lab environment as well as this editor, which is called VS Code. But for now, we want to see how you would go from the algorithm which we just wrote, which we've written down here as comments. These are things that the computer doesn't pay any attention to when it runs our code, and take that algorithm and turn it into Python code. So what I'm starting with here is def is prime of n, so that's the name of the function. I'm defining this function. It takes one parameter called n. And I've also written a little main which says what to do with our program, so we call that at the end here. And it's going to just say for numbers from -2 inclusive to 13 exclusive, it's going to say checking if that number is prime and tell us the answer so we can see what our function did. So let's go in here, and what we want to do is line by line translate these comments into Python code. So the first thing we said to do is check if n is less than or equal to 1. Doesn't really matter that I misspelled that, but I'll just fix it. And so when we want to check a condition, that's an if statement. If n less than or equal to 1. Okay? And then we said, if so, answer no. So when we know the answer to our function, we're going to return a value. Now in this case, we said answer no. That could mean that we want to give back the string no, which is a word, but more commonly in programming, when we want to return a yes-no value, we want a Boolean, something that's true or false. So we're going to return false, which says, hey, this was not prime. Next, we want to count from 2 to n and call each number I. When we want to count, that's a for loop. So I'm going to say for I in range 2 to n. So range gives us all the numbers inclusive of the start and exclusive of the end. So that's exactly what we want there. And then we want to check if n mod I is 0. So again, we want to check a condition, so we want an if statement. And in this case, we want n mod I is equal to 0. So mod is the operator, it's the percent operator, and that's the remainder when you do division. So this says basically if n is evenly divisible by 0. If so if we're inside here, we want to answer no. We want to give back false. Now remember, I really like to put a pass here to explicitly indicate that we're at the end of this loop. And then after this loop, after we finish counting, we want to return yes, which would be true. Okay? And let me just underscore why we want this pass here. If we put this inside the loop, if we indented this over, then we would just count 2, and if the number is not even, we'd return true right away. But we want to do this after we finish that. So we want to put a pass here so that it's very explicit that this is the end of the loop. Now that we've translated this code, let's run it. So I'm going to come up here and click play. And you'll see that this output's a little long for this screen, so I have to scroll back. But it says checking if -2 is prime, answer is false. Checking if -1 is prime, answer is false, and so on. And our prime numbers like 2 and 3 and 7 are coming out as true. There's 11, right? So with that, we're pretty happy with our prime function. We might want to test it more. We'll talk about testing soon. But to see just how to translate this algorithm into code, you've now seen how we write down the steps as comments and line by line go through and turn each one into a Python construct.